Welcome back, folks. Now let's understand this circuit a little bit better. So let's go a little deeper and check all the values of the different components of this circuit. So let me first go by drawing this circuit. So if you look at this circuit, this is how this circuit looks like. So if I had to draw it as a circuit diagram, we have a battery that's connected to a resistor, and that's how you denote a resistor. And that's how you denote a battery. This is the positive and this is the negative. And then finally, it's connected to an LED. This is how you denote an LED. That is how you show a circuit diagram of this specific circuit, which is it has a resistor, it has a battery, and it has an LED. Now we want to figure out what are the different values of all of them. So from the battery, we know that the voltage is equal to 3 volts, but it's not exactly 3 volts, and we know that, we checked that last time, but we'll do that once again. So I'm going to bring out the multimeter, and I'm going to take out this battery, and I'm going to check exactly what the voltage is on the battery right now. As the battery gets used up more and more, this voltage will keep coming lower and lower and lower. Right now, the exact voltage of the battery is about 2.7778. Now it's about, 2.8. Let's take it as 2.8 volts. Okay, so we're going to write that down. The actual voltage over here is equal to 2.8 volts. Next, we need to know what the resistor carries. So I'll put the battery back into the system, and I'll grab this resistor. And I will repeat the same process. I'll grab the multimeter and check what the reading is on the multimeter across the resistor. So, and I have to remember to change this to somewhere over there in terms of resistance. And the exact resistance is 984 ohms. So let me write that down. The resistance on this is equal to 985 ohms, which is approximately 1 kilo ohms. 985. Lastly, I need to know what is the current that is going around in this circuit. Now the current is going to flow in this direction from positive to negative, and it's going to go through all of the different components of the circuit. So to figure out the current, once again, I'm going to go back to my multimeter. And I'm going to go to the A section with the DC sign. So that's basically A stands for amps or amperes. And the sign that we use for current on a circuit is actually a small I. One of the reasons is because most of the other things are used up. But I stands for current. If we check the current on this, we can find that the current is exactly 2.75 milliamps. So 2.75 milliamps. So if you look at this circuit very carefully, something very interesting is happening over here. And I don't know if you're able to see this relationship yet, but I want you to figure this out. There's a very important relationship between your resistance, your current, and your voltage that's going on in this circuit, and actually in all the electronic circuits. This is the most fundamental relationship that is there in every single electronic circuit. And I want you guys to figure it out. So next, in the quiz below, you can see a few different options, and I want you to go and try and figure out what is this right relationship between the voltage, the current, and the resistance. This is going to be approximate, but you'll be able to figure out in a perfect world scenario what this relationship looks like. Of course, we are losing a little bit of voltage between the wires as well and getting some resistance from there. So hence it's going to be approximate, but you'll get a very, very close, beautiful relationship that comes out of this. And that's what I want you to figure out next and answer the question below. Good luck.